So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list with basic operations pattern. In previous video we have already discussed what is linked list, how to design linked list using iterative and recursive code. But why we are learning through recursion? Because you know recursion is very important. So we are practicing recursion as much as possible. So in this video today we will learn how to search in a linked list and how to insert node at different positions in the linked list. So let's try to understand the very first problem, which is search in a linked list. So as you can see the problem statement, you will be given key which is 3 here, and you have to search in the entire linked list by iterating one by one or recursively also. Now let's see the time constraint. It says number of nodes can be 10 power 5. Okay, so definitely we have to solve this linearly, and using the brute force code or optimized code in linked list we will mostly have linear solutions only. You will rarely see any n square or more than that solutions, but mostly in linked list we will have 2n 3n solutions as brute force, and when you will optimize you will make n by 2 or O of n as better solution. Okay, so now let's try to solve this problem and let's see how can we do it. So as you know that in linked list the very first node called head node, and we always try not to move the head node because in the linked list we don't have indexing, so whatever we have is this pointer. So it is very important to remember what was the first node, then only whatever changes you are going to do it is valid, because no matter whatever changes you are going to do, but what if head pointer is not there and you have no such pointer at 1, so means you will lose your linked list permanently. So it is very important not to touch head pointer, and for the reference make a alias, let's call it current pointer, and do whatever you want with the current pointer itself. So in this case what we want to do, in the function we will be given our key, and let's say key is equal to 4. So we have to search a node with value 4 here. So how can we search it? We can only search when we iteratively reach every node and check if there means head dot value or current dot value matches with key. If yes, we'll simply return true. If no, we have to return false. Very simple task, but how can we do it? Definitely we want a alias, means we will make a current node of type node and we will refer it with head. Means we don't want to move head pointer, but we want to make a reference node called current pointer. But till when or till what point the current can move? Definitely if my current is standing here, can I say my node is existing? Yes. Now we'll move current is equal to current dot next, we'll move to 2. Now next time 3, now next time 4. Suppose we have to search 6 and you will end up moving to null. So can you move further? Means is there any possibility? Why I'm saying, because we are moving through current is equal to current dot next, this piece of code, correct? So when you will reach this null has no such dot next pointer, so this will give you null pointer exception. So we want to save from this, so definitely we will move our current until it does not hit any null pointer. So what we have to write? We have to simply write in a while function ki while my current not is equal to null. Okay. Now in this what I want to do? I have to check if that node value is matching with key or not. So definitely we will, so we'll write if current dot value or data, whatever it is mentioned in the constructor, if this matches with key which has been given in the function, we will return true. Okay. But initially where we are at 1. Does this matches with 4? No. So we want to move to the next pointer. What we want to move? Head or current? Definitely current. So how we can move? Definitely by this line of code, which is current is equal to current dot next. Very simple. Again 2 matches? No. Now 3 matches? No. Now 4 matches? Yes. So we will return true from here, and that's what expected. But what if my key was 6? So what you will do? Again, this 4 matches? No. This 5 matches? No. Now you are at null. So this while loop will say my current is not is equal to null. No, it is null. So now you will come outside the while loop. So what was expected? expected answer was false because you have not found the value 6. So what you have to return? You have to return false, and that we will write outside the while loop. It means we have searched through entire linked list, but we were not able to find that value. So what is the time complexity for it? As you can see, you are running a current from head pointer till null, and the question says number of nodes can be 10 power 5. So you are running for O of n. So in this case, the time complexity will be O of n, which is 10 power 5. Definitely it is safe. Yes. Why I said safe when seeing 10 power 5? Because you know beyond 10 power 8 the code might give you TLE, and beyond 10 power 9 or at 10 power 9 for sure it will give you TLE. And what is the reason behind it? We have discussed all this in our time and space complexity video. I'll definitely add the link somewhere here. You can check it out, or you can check it out from the description as well. So this was through iteration. But how is it possible? Means how can we write through recursion? Let's erase this first. How can we write through recursion? Definitely in recursion also we are sure with two things. What? We have current, right? You know that in recursion you don't need to create current. Why? Because recursion always saves its call in the stack memory, correct? And every function call remember their own heads. So when you will come out of the functions, means when you will return from the functions, every function remember their own head. So at the end, in the starting, whatever was the head, let's say 1, that will get returned, correct? So our task is very simple. Ki if our head dot value is equal to key, we know one thing. What? Return true. Okay. Now we want to check for the new nodes, means next nodes. So let's say this is a function we have, and in this we have head, and in this we have key. Okay. So now after checking if our head value matches, if it does not match, we want to call the function. So we'll call the same function with head dot next. Yes. So that in the next function we want new head, but we want to save a search for the same key. But one more thing, don't you think we have to write the base case, because recursion will never stop? So what is the base case? What do you think? Suppose in this case we have to search for. So your current, you are present at 1. Yes. Is the value matches? No. Okay. So now what you will do? You will call the next function. So can I say here you will have your function head, let's say 1. Okay. Now the next call function 2. Now next call function 3. Now next call function. For 4 you call. For 4 you called and you checked here head value matches with key. Yes, you returned true. So now what will get returned? From here you returned true. So true will get returned, and now this will also get returned to their parent calls. Yes. So now this will get returned to true. Now this will get returned to true, and this will get returned true. But in this case, so it found it. What if it does not? Or what if it will go out of index? Out of index means outside the linked list. Yes. So now we are at 4. Okay. Now we'll move for the next call 5. Let's say we have to find 6. Correct. So now the next function will save here function 5. Yes. Function 5. And now again we'll go for the next, which is head dot next, means 5 dot next. What is there at 5 dot next? Null. So we'll go here. Correct. Do you think null dot, like null has dot value? No. If you will add, it will also give you error. So what is that base case? If my head is null, means what was the condition in the while loop, that will become the base case here. So what is the base case? If head is equal to null, return false, saying you have not found anything. Okay. So false will get returned. Yes. Now this false will get returned. This false will get returned. This false will get returned, and false will get returned to the final function call. Okay. So now let's write the code for this. So this is the iterative code in Java, what we discussed earlier. This is the iterative code in C++, and here is the iterative code in Python. So now we'll write the recursive code. So in the recursive code, what we want to write the base case first. If my head is equal to null, we want to return false. Correct? But what if head dot value data, okay, matches with my key? If it is so, we will return true. But If not, we have to iteratively go to the next nodes. So we will return whatever the same search key functions return. So search key, we will move to the next pointer, which is head.next, correct? You know that in recursion, instead of doing manually, which we were doing in while loop, key head is equal to head.next. Here we will send in parameter, okay? And the key will be same, and that's what we will call. So now let's run the code. As you can see, it has been passed. So now let's try to submit this. Again, the time complexity will be O of n. Why? Because recursively also we are only moving to all the nodes at once. But because of the internal stack memory or function calls getting saved in the internal stack, it uses extra space complexity. So definitely the iterative code is far better approach. But again, we have to learn the recursion also, we have to see different solutions also. That is why we discussed both the iterative and recursive code. So I hope you understood. If you have any doubt, do let me know in the comment section. Until then, if you have submitted, understood, then you are eligible to go in the sheet and mark the next question as done. Now let's see the next question. Question says we have to insert the nodes in the linked list. But here the question says we have to insert at the end of the linked list. So can I say we will iterate through the entire linked list until the node becomes null, and at the same point we will add the new node? Yes, it is very easy. So in the linked list we can have three types of insertion, and those three types of insertion are, let's suppose this is the linked list, we have 1, 2, 3, 4, okay, and here we have null. Now the question is key, let's suppose you have to insert a linked list with value 5 at the beginning of the linked list. Means you have to insert the node 5 at the starting. So you know in the linked list we have head pointer, correct? So how can we connect? Let's say you have to insert value 5. So definitely you will make a node with value 5. Yes. So how to connect this? Can I say if I will connect current dot next to head, and also I will make current as head. Again, what I said, first so we will make a current node with new node, and let's say we have key, so with the key value. So we will say 5 has been created. Now we want to connect this current dot next to our head pointer. Yes. So I can say this has been connected, but still it has been connected. But as of now, if you will return head, so only this much linked list will get returned. It will say 5 has not been inserted because it does not know the address of 5. We cannot reverse back, correct? Yes. So for that, what we want to say, we still have the track of current. So now we'll make the head as current. So now we'll move the head pointer from here and we will make the head this. And now we can return our head. Yes, now we can return, and now when we return, it will say 5, 1, 2, 3, 4. This, it will see this as a new linked list. So this was insertion of node at the beginning of the linked list. Now let's see insertion of node in between the linked list. In between means, let's suppose it will say ki you have a position given. Okay, so this is the head we have. Okay, and let's say it gives the index, it can give you the count also, ki hey, after 2 nodes inserted. Okay, or also it can say ki insert a new node with value 5 after the node with value 2. Okay, so in both the cases it's same. Means if it says after 2 nodes, count of 2 nodes, so we can run the counter while like number of times we are moving. So if you are initially at head, so let's say current, so you will say count 1. Now you will move to current, you will say count 2. So after 2 you have to insert, right? So your current will be here after count 2. So we have to insert. So now if our count matches, means what we'll do, we will run our while loop while our count is less than equal to 2, correct? So now what we'll do, we'll say current, which is here, initially current here, correct? Yeah. So current is equal to current dot next. So this will come here. Yes. Can I say I have to insert here only? So I don't want to move this for 2 times. I just want to move this for 1 time. Okay. So I will not add equal to operator, and I will start my count with 1. So now what I will do, I will do count plus plus here, and now my count will become 2. So it will say, is this count 2 is less than 2? No, it is false. So now it will stop here. Now I have to add 5. I have to add 5. So definitely I will make a new node 5. Let's say new node. Yes. Now my current is pointing to 2, and I have to insert 5 here. Again, I have to insert 5 here. So what will I do? I have 5 here, okay, and 2 is pointing to 3. So if you will save, like if you will see what is current.next currently, can I say current.next is nothing but 3? So if you will write current.next is equal to 5, so this will be broken. Remember that. And now if you will print head, it will say 1, 2, 5. 3 is lost. Means 3, 4, everything are lost. So we don't want to disconnect. So don't disconnect the nodes until you save those next nodes in some another variable. So what we'll do, in the temp variable of type node, we will save our current.next. Correct? So I can say 3 is referenced by temporary pointer. And now we'll say current, which is 2, dot next, which is currently pointing to 3. I want to point to new node. New node. So now what will happen? This will break and 2 will get connected to 5. But again, I want to connect this 5 with 3. Then only I can say now 5 has been inserted in between. So what will I do? I will write new node dot next. So currently new node dot next is pointing to null, but I want to point it to 3, which is nothing but temp. So now this will point to 3. Done. And now we can say return head 1, 2, 5, 3 and 4. So this was insertion of a node inside or in between the linked list. Okay, so this was using the counter variable. If the question says do or insert using the value, then keep running the current pointer until it matches with that value. I hope you can do that. Okay, so this was the second problem statement. Now the third problem statement will be insert the node, yes, at the last. Yes, you are right. Okay, so at the last, so we have to create a new linked list, like new node 5, let's call it new node. Okay, yes, and pointing to null, and we have to insert at the last. As you know, it is very simple. Why I said? Because we have head, okay, and we have to iterate until its next pointer pointing to null. Can I say that? Why not the head pointer moves? First point is we cannot move head. Okay, what we will make a alias, let's say current. Okay, and we'll move this current. Now what we'll do, current is here, we want to insert at the last, right? So we'll move this current at 2. Is this end? No. 3. Is this end? No. 4. Is this end? No. Yes, it's null, right? Its next pointer is null. So we'll stop here. Why I will stop here? Because after 4 we have to add 5. So why you want to go at null? So when we stopped, can I say while my current dot next not is equal to null, keep on moving. Keep on moving means current is equal to current dot next. Done. And now where I am, where my current is pointing to 4, what I want to do, I want to attach this 5. So can I write, yes, what I have to write, current dot next is equal to new node. So now this null will get removed and 4 will get connected to this. And now return head, simply return head. So what will happen? You will return head 1, 2, 3, 4, 5. So yes, you have inserted at the end. So what is the time complexity for this? O of n, because you have iterated it till the last and you connected this. Correct? O of n. Space complexity constant. You have not used any extra space. Instead you took few variables, yes, and that is constant. So this was the iterative code to insert the node at the end. Now how can we do this using the recursion? But before that, let's see the code and let's run this. So here is the code in Java. First we checked what if our head can be null. Why? Because if you see in the constraint, it says the number of nodes can be 0 also. So number of nodes 0 means head can be null, right? So if your head is null, correct? So if your head is null and you have to insert at the end, so can I say your entire linked list is null and you have to insert at the end, means the new node is the head itself, correct? So make a new node and return that. Yes. So if the head is null, then return the new node. Which new node? Which you created here with the value x. Otherwise, make a alias current, keep on moving until it's next, and at the end attach it and return your head. Correct? Now let's try to run this and let's submit this code. Submitted, very easy. So this was your code in Java for the iteration. Here is your code in C++ for the iteration, means iterative code, and here is the Python iterative code. But now we would like to discuss the recursive code for it, means how to insert at the end. If you know, if you understood, I would definitely like to request you all to try on your own. So we'll make a function, and in the function we will have our head and the value which we want to insert. But the question is, where we want to insert? Here though, like in the iterative code, you went till its next is null, means till 4, and after that you connected, correct? But you have to write the base case. When you want to return, can I say when my node, like current node is null, correct? So base case will be if my head is equal to null. Done. But what I want to return? Come on, what I want to return? Null. So if you will return null, it will get saved here, null, it will get saved here. So entire linked list will become null. Don't you think so? So can I say if my current pointer is pointing to a value which is null, why not do one thing? I am at null and I know one thing, I am supposed to create a node there, correct? So I will create a node, return new node with value x. Yes. So now 5 will get created and 5 will get returned. So I need this 5 to get saved to previous call. Previous means definitely it will be head, yes. But where? Head dot next. So I know one thing, I will call the function head dot next, yes, x will be same. But this, instead of returning, I want to save in head dot next. Okay, what I did. Okay. Let's try to understand this. We will have our stack. So initially, where we are here, like head pointer, you know in recursion we don't make alias because stack calls will remember their own heads, correct? So initially we will have function. In function we have head, let's say 1. Okay. Next time we will have function 2. Next time we will have function 3. Next time we will have function 4. Next time we will have function for null. Can I say? So when I have head null, I am creating a new node, I am returning it. Okay. Okay. So what we will do, we will return this 5 here. And now this 5, what we did, head dot next. So previously what was the head? Because function return remembers it, right? So initially, like previously, head was 4. And I have got this 5 as the return statement. So can I say this 5 and this 4, I want to connect them. But how can I connect? Definitely 4 head dot next 5. So definitely instead of simply calling or adding a return function this, I would like to add it. So head dot next is equal to this. Now again this 5 will get 5 has been added to this, means 4 5. So I can say connected, but now 4 will get returned and it needs to be connected in 3 dot next. But you will say 3 though is already connected with 4. Why you want to do it? Because in recursion your code statement lines should be same. So initially, like for the last one you wanted to connect, so you added this line. But now as the line is already added in the function, so when you will revert back, it will again save it. Anyhow, it does not make sense for such cases because 3 is already connected to 4, 2 is already connected to 3, but because we wanted to connect this one, so it will again get reconnected. Means earlier also they were referencing to the same address, now also it will reference to the same address. Okay. So now again 3 will get saved to 4. Now 3 will get returned. But wait, we have saved, we have not returned. What do we want to return? See, 5 get added to 4, correct? Now 4 wants to return back 3. Now 3 will get added to 4. Now 3 wants to get returned back. So can I say after this line we have to write return head? Yes. And you're done. You will return 5, you will return 4. 4 means 4 with 5. Now you will return 3 means 3 with 4 with 5. Now you will return 2 means 2 with 3 with 4 and with 5. And now you will return finally head. Now 1 with 2 with 3 with 4 and with 5. So at the end 1 will get returned. So I will return this much lines of code, and we will write ki if our head is equal to null, which is our base case, we have to return new node with that value x, correct? So this was a base case. Now after that we want to call the same function insert at end. Okay, we'll call the same function with head dot next, because next time we want to move our head ahead. X will be same, yes, but this I want to add in my head dot next, correct? Yes, and also we want to return our head, correct? So now let's run the code and let's submit this. So it will get submitted definitely. Time complexity will still be O of n, but space will also be O of n. Why space will be O of n? Because we are using internal memory. So that's it. If you understood this also, definitely in the sheet we can mark insert at head, tail and nth position also. So I hope you understood. If yes, please do submit the code on your own. Do let me know in the comment section how was the video, what else you want, and also you can find the sheet link, which is completely free, and also my social media where you can reach out to me for any kind of guidance below in the description. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.